The year is 1907. A British experimenter named H.J. Round is tinkering with a crystal of silicon carbide. What he discovers will change the world. Imagine a time when the glow of electric light was a novelty. A marvel even. The streets lit by gas lamps and homes by candlelight. Enter H.J. Round, a British experimenter who in 1907 stumbled upon a phenomenon that would brighten the world in ways he could hardly have imagined. While tinkering with a crystal of silicon carbide, he observed a faint yellow light emitted from it when he applied a voltage. This was the birth of electroluminescence, the principle that underpins the technology of light-emitting diodes, more commonly known as LEDs. Fast forward to 1962. The world had moved on from gas lamps and candles, and electric lights were the norm. In this new age of technology, an engineer at General Electric named Nick Holonyak Jr. invented the first practical LED. Unlike the faint glow of Round's silicon carbide, Holonyak's LED emitted a much brighter, low-intensity infrared light. However, it was red, not the familiar warm white of incandescent bulbs. But it was a start, a significant one at that. Over the next few decades, LED technology evolved at a breakneck pace. Scientists and engineers across the globe were captivated by this efficient new way to produce light. They developed LEDs that could emit a variety of colors, from red to green and even yellow. These little diodes started to find their way into every corner of our lives, from the humble remote control to the grandeur of Times Square billboards. Yet, as the color spectrum of LEDs expanded, one color proved particularly elusive: blue. Blue, the color of the sky and the sea, the color that when combined with red and green, can produce white light. The creation of a blue LED became a sort of holy grail in the world of science. But why was it so difficult to produce? And how did we eventually overcome this challenge? But as LED technology evolved, one color proved particularly elusive: blue. Let's delve into why. To understand why blue was such a challenge, we need to understand how LEDs work. Now, light-emitting diodes, or LEDs, aren't your average light bulbs. They're a type of semiconductor, and it's this semiconducting property that allows them to emit light. Here's the lowdown. Semiconductors are materials whose conductivity sits somewhere between that of an insulator and a conductor. They're made up of atoms bonded together, each holding onto a cloud of electrons. But there's a catch. These electrons can only move around, and hence conduct electricity, if they have enough energy to jump from the valence band, where they're bound to the atoms, to the conduction band, where they're free to move about. In an LED, this leap is exactly what we want to happen. When an electron makes this jump, it leaves behind a hole in the valence band. Sooner or later, another electron will fill this hole, falling from the conduction band and releasing energy as it does so. This energy is released in the form of light, the color of which is determined by the size of the energy gap between the two bands. Now here's where the color blue becomes a bit of a troublemaker. Blue light has a shorter wavelength, meaning it's higher in energy. To produce blue light, you need a larger energy gap in your semiconductor. But finding a material that can withstand this higher energy, and that's also efficient and cost-effective, well, that's where the real challenge lies. In essence, the hurdle to creating a blue LED was not just about finding a material that could emit blue light, but finding one that could do it well. It was about balancing the need for high energy with the practicalities of cost and efficiency. It was a puzzle that took decades to solve, but the result revolutionized the way we light our world today. So the challenge was clear: how to create a semiconductor material that could withstand the high energies needed to produce blue light. It was a challenge that puzzled scientists for decades, but in the 1990s, that would all change. In this fascinating chapter of our technological history, three brilliant minds, Shuji Nakamura, Isamu Akasaki, and Hiroshi Amano, took center stage. They dared to venture where no one had successfully gone before, into the realm of blue light-emitting diodes, or LEDs. Let's take a step back. Why was making a blue LED so difficult? Well, it comes down to the materials. In the LED world, different materials emit different colors of light. The materials that emit blue light, like gallium nitride, were notoriously difficult to work with. They were hard to purify and even harder to form into the high-quality crystals needed for LEDs. Most scientists had given up on gallium nitride, but not Nakamura, Akasaki, and Amano. They saw potential where others saw dead ends. Through tireless research, they developed a way to grow high-quality gallium nitride crystals. This was the key that unlocked the door to blue LEDs, but their work didn't stop there. They had to turn these crystals into a functioning LED. This involved sandwiching a thin layer of the gallium nitride crystal between two other layers, creating a sort of LED sandwich. When electricity is applied to this sandwich, the energy jumps from one layer to another, creating light. And not just any light, blue light. For the first time, scientists had a reliable, efficient way to produce blue LEDs. The work of Nakamura, Akasaki, and Amano was groundbreaking. They didn't just solve a scientific puzzle, they revolutionized technology. From our smartphones to our televisions, blue LEDs are everywhere. They're in our hospitals, our homes, even our spaceships. They've transformed our world, making it brighter, more efficient, and more connected. Their discovery wasn't just a scientific triumph, it opened up a world of possibilities. And we've only just begun to explore what that world can offer. So the next time you look at the blue light on your phone or television, remember the incredible journey it took to get there. From our smartphones to our televisions, blue LEDs are now everywhere, but their impact goes far beyond our screens. Indeed, the advent of blue LEDs has brought about a revolution in lighting technology. Their unique properties have enabled the creation of white LED light, which is now a cornerstone of energy-efficient lighting. This was achieved by combining blue LEDs with phosphors, which absorb a portion of the blue light and emit yellow light. The blend of this yellow light with the remaining blue light appears as white to our eyes, and voila, we have white LED light. This innovation has had a profound impact on industries worldwide. From automotive to aviation, from healthcare to home decor, the applications of white LED light are as diverse as they are transformative. Let's take a moment to appreciate the magnitude of this change. In the automotive industry, for instance, LED lights are now the go-to choice for headlights due to their superior brightness and energy efficiency. This has not only improved driving safety, but has also reduced energy consumption, contributing to the industry's sustainability efforts. In healthcare, white LED light is used in a wide variety of medical devices and diagnostic tools. Its high brightness and low energy consumption have made it an invaluable resource in operating rooms and patient care. And let's not forget about our homes. The energy efficiency of LED lighting has made it a popular choice for both indoor and outdoor lighting. This has helped households significantly reduce their energy consumption, making a substantial contribution to global sustainability efforts. The impact of blue LEDs, therefore, extends far beyond the cool blue light on our screens. They have revolutionized industries, improved our daily lives, and contributed immensely to our planet's sustainability. So next time you look at your screen, take a moment to appreciate the blue light that made it all possible. The story of the blue LED is a testament to human ingenuity and perseverance. This journey, spanning decades of research, numerous trials, and countless failures, is emblematic of our relentless pursuit of knowledge and innovation. We started with the discovery of electroluminescence, a phenomenon that brought about the dawn of LED technology. Scientists and engineers then dedicated their lives to unraveling the mysteries of this technology, dissecting the physics of LED light, and understanding its potential. The challenge of creating the elusive blue LED seemed insurmountable. But through sheer determination and a spark of genius, we witnessed the breakthrough of blue LEDs. It was a landmark moment that revolutionized the technology landscape, opening up a world of possibilities previously thought unattainable. Blue LEDs now illuminate our lives in more ways than one. They are integral to our digital screens, from smartphones to televisions, and play a crucial role in optical storage devices, like Blu-ray disc players. They are also key to the development of white LEDs, which are now the go-to for energy-efficient lighting around the globe. But the significance of blue LEDs extends far beyond these everyday applications. They have become a cornerstone in advancing fields that push the boundaries of what technology can do. One such field is quantum computing, where blue LEDs are used to trap and manipulate ions, enabling the creation of quantum bits or qubits. This has paved the way for computers that are exponentially faster and more powerful than anything we have today. So, while the blue LED might seem like just another component in your electronic devices, its impact is far-reaching. It stands as a beacon of human achievement, highlighting how we can overcome significant challenges through innovation and tenacity. It exemplifies how a seemingly small and simple device can have profound implications on technology and society. So here's to the blue LED, a little piece of technology with a big impact on our world. We hope you enjoyed our journey into the world of blue LEDs. If you found this video enlightening, we'd appreciate if you could tap the like button and share it with your fellow tech enthusiasts. Don't forget to hit subscribe to stay updated with our latest explorations into technology's untold stories. We'd love to hear your thoughts on this video and any suggestions for future topics, so feel free to drop a comment below. Until next time, keep exploring the fascinating world of technology.